Yep. And again, today we're doing 6.2, which is on parallelograms. Have you ever learned about parallelograms? Is that something you guys have talked about? Does anyone remember what it means to be a parallelogram? So familiar, but we don't really remember it. I'm going to tell you what it is. I just was wondering if you guys knew. Yep. That's the basic definition of a parallelogram. We're actually going to skip this first box right now. That's going to be like the spark notes that we make at the end. So just leave that one blank and we'll come back and fill that back in. We're going to learn, I think, 5 things today about parallelograms. And the first thing, you guys remember, you've learned about a parallelogram. It's a quadrilateral. It's a 4-sided figure. And it has 2 pairs of opposite sides that are parallel, not congruent. I'm getting a little ahead of myself. That are parallel. Remember that we want to mark that they're parallel, or if it was marked on a paper, this is what we would see. We'd see that these are parallel with the little arrows. I would also do 2 little arrows this way. I just want to make sure we all have our masks on, our AirPods out, which we're all ready for class. Okay. All right. Parallel, we mark with the 2 little arrows. They're different because these 2 are parallel to each other, but they're not parallel to these 2. But these 2 are parallel, so I need to show that a little bit differently. Okay. Next thing, I kind of got ahead of myself on the last one, but in addition to both sides being parallel, they are also congruent to each other. So opposite sides are congruent as well. I'm going to mark that again, but this time with congruent marks. You do 1 congruent mark for like the up and down or the side to side ones, and you do 2 for the other 2 to show that those are all congruent. So if I told you this side was 16, that means that the other side is also 16. I could also have given you an expression. So instead of 16, I maybe could have written like 1 plus 2x, and then we could find x by knowing that they're congruent to each other. So that's going to be useful in a little bit. Now we're going to move into angles. So this next one says if a quad is look at this weird shape. If you want to, you can use shorthand by drawing a little square, rectangle, parallelogram like that. You also can write it this way. We can abbreviate parallelogram by writing p-gram. Honestly, I've said parallelogram like 20,000 times between today and yesterday. And so if you're writing it and you write parallelogram, 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 it gets like to be a lot after a while. So when we were writing it, you can abbreviate it as a p-gram and I will know what you're talking about. All right, now we're looking at angles. So we just did sides are both parallel and congruent. Now we're doing angles. If I have angles that are next to each other, consecutive, those angles are supplementary. Let's explore what that means, why that is, and what that looks like. So consecutive means next to each other. So if I look at this big figure right here, parallelogram LOVE, I can know that L and E are supplementary. So let's say I labeled them. Let's say L was, 50. That means E would be 130. Does anyone know why I'm allowed to do that? Why do I know that? Why do I know that those are supplementary? Give me more words than that. That's what I want, Maggie. I want us to remember back to our lines. Remember lines back in chapter 3 where we were like, oh, okay, LO is parallel to EV, and then I've got a transversal of LE. If you remember all the way back to my parallel lines cut by a transversal, the angles that are next to each other are called consecutive interior, and consecutive interior angles are sup. So I'm going to go down here to see underneath why is that true. I'm going to write if lines are parallel, then consecutive interior angles sup. We used to write that all the time. Now we're not going to write it that much. We're just writing it now to remind ourselves why that is. Based on that theorem that we learned back in chapter 3, we're now in chapter 6 and we're still using it in this parallelogram. Okay. If I were to go back to this picture, I could also have looked at different parallel lines. I could have looked at like these two. I could have looked at OV. Oh, that's a terrible line. OV and LE. Those guys are also parallel. And their transversal is LO. So that makes angle O and angle L also supplementary. So I could label angle O 130. I also could have looked at the same set of parallel lines and done the transversal at EV and known that angle E and angle V were supplementary, which makes angle V 150. So we can rotate kind of all the way around because we know these pairs are parallel and these pairs are parallel. So we're allowed to rotate around. Yeah, that says 50. Okay. One thing while I'm here, you notice a little box next to it. This is something I think that we do a good job with, but I wanted to remind us. We can call this parallelogram LOVE, LOVE, or we could go from a different vertex and start and go VELO. You can't like cut across the shape. So I could not go like VEOL. If I write a parallelogram like this, I don't care where it starts, but you are still going to go all the way around. You don't get to like cut through the shape to name your vertices. Pick a vertex, go either direction, but go all the way around, and then you're done. So I need you to name them in an order, which means either you're going around this way or you can go counterclockwise. It does not matter to me. Okay, so we've done 3 things so far. What's one thing we've done? What's one thing you know about parallelograms? Who can give me one? Who can give me one thing you've learned about parallelograms? Jane, give me one. Good, they've got 2 pairs of opposite sides that are parallel. Who can give me another thing we know about parallelograms? Looking for 2 more. We just went over 2 other ones.
If lines are parallel, then the consecutive interior angles are supplementary.
That is true. That's not about parallelograms, though. That's about parallel lines. Colin, give me another one.
The angles opposite of each other.
Oh, we don't know that yet. Sides, very good. And then somebody match what Ben was saying about lines with parallelograms. Why is it important that we learn that lines are parallel, then consecutive interior angles are sub? How did that help? Good, so that helped. What Ben told me is what helped us know that consecutive angles in a parallelogram are supplementary. Very good. All right, we got 2 more things to learn. This next one is, if a quad is a parallelogram, Colin kind of previewed this, even though he didn't realize it. Opposite angles are going to be congruent. Did you notice when we did our LOVE shape, L and V were both 50 and O and E were both 130? We did that by just doing our supplementary angles, but what happens then is my opposite angles, O and E, are both 130. And L and V are both 50. So opposite angles are congruent. Let's do an example with that. What if I told you that angle M was 110 degrees? Who can name one other angle in that shape? 1 person can, 2 people can, 3 people, 4 people, 5 people, 6 people, 7 people, 8 people. Megan, name one more angle here. T is 110 degrees. Why? Very good. All right, so Megan said M and T are opposite, so they're congruent, which is 110. Who can give me another angle? 1, 2, 3, 4, 5. Michael? Why? Say that again. Equals 180. Is A or H 70? They're both 70. Okay, tried to trick you. They're both 70 because they're also opposite angles, which are also congruent, but they're supplementary to the one next to them. Very good. All right, just keeping us on our toes. The last one I don't think is one that, like, it's one I always forget. It's one you probably don't already know. This one is talking about the diagonals. The diagonals bisect each other. So remember, a diagonal goes from like one vertex to another vertex across through the triangle. These bisect each other. Another way of thinking about this is saying that the diagonals share a midpoint. That means that GA and AO are congruent, and it means that MA and EA are also congruent. Now, that being said, there's two kind of common misconceptions that we need to talk about. When we say diagonals bisect each other, sometimes we think then that the diagonals of the parallelogram are congruent. It's kind of hard to see here, but that would mean that ME is congruent to GO. Think in your head, do those look like the same length? Think either yes, think either no. I think this is kind of a hard one to see, so I'm going to draw a very exaggerated one. That's a parallelogram, right? Are these diagonals? No, that's not what I want. Never mind. Let me try again. I'm gonna have to go backwards. I thought I could do it forwards and I can't. Someone making fun of my shape? Would you argue this is not a parallelogram? Yeah, it is, right? Those are parallel. These are parallel. Were their diagonals congruent to each other? No, you even watched me draw the diagonals first. I've got this itty bitty one and I've got this very, very long one. The diagonals, just because they bisect each other, does not make them congruent. So I'm going to write no. Are the diagonals of a parallelogram congruent? No. Now, do the diagonals of a parallelogram bisect the angles? Let's go look. If I'm looking here at angle G, are those two smaller angles, are those congruent? Was G bisected? Is this one congruent to this one? I don't think so. This itty bitty angle right here, this angle looks a lot bigger, right? So I tried, this is also not a great one, but I think it's a little exaggerated enough for us to see those are not congruent to each other, so it is not bisected as an angle. So I'm gonna write down here no as well. All right. Okay, we're gonna go to do the box at the top. If you have nothing else on your page, you at least need the box at the top that we're about to fill in. What I'm gonna take is I'm gonna just zoom in on the box so I'm not, giving us all motion sickness. Say again. Share. Yep, I'm sorry, Michael. I'm literally taking the 5 things we just learned and writing them in shorthand up top. So the first thing we learned was the definition. So if a quad is a parallelogram, we're going to write then 2 pairs of opposite sides are parallel. Oh no. Get off my thing. What'd you say? No, I'm like on. Somebody's trying to bomb our class. Get off. I like literally can't do anything. Well, we'll just sit and look at each other for a minute. I'm going to keep writing. What you can do is just listen to me. So what did you have on the first line? Did you guys get what I said on the first line? 2 pairs of opposite sides are parallel. The second line I'm going to write are opposite sides are congruent. I'm writing OPP sides congruent mark. Oh, we're back. Okay, whew. All right, now you can see. You don't have to just listen to me. So Marisol, for you at home, we could not see the board. Someone's trying to airplay over me. So that's why we had a nice little intermission. Also, for anyone watching the YouTube later, sorry about that. Number 3 was about the consecutive angles. So we're going to write consecutive angles are sup. Again, if you have nothing else written on your paper, you should at least have this. If you have nothing else, if you learn nothing from today, you should at least have these 5 things. Number 4 is about opposite angles. Opposite angles are congruent. And the last one's the diagonals. Diagonals bisect each other. That to me is the hardest one, but we all struggle with different things. So I personally know that I'm gonna have to be really careful about diagonals. You might think, oh, I'm good with diagonals, but the angles are really tough for me. Whatever it is, we gotta figure it out. We gotta fix it. All right, I'm gonna move on. Any questions? Do I need to wait a minute? I can wait a minute. You really should have exactly what I have written down. This is kind of the shortest way to do it and the best description. When you're done, I want you to flip over and look at the first problem on the back because I'm going to need help on that. When you're done, flip over, look at the first problem on the back. All right, am I waiting on anyone for this? Everybody good? Yes, no, maybe? Yes, okay, I'm going. All right, these are really good examples to do too. All the ones we do will be like ones on your homework. So let's look at this first one. I need to find measure of angle L and measure of angle J. If I know JKLM is a parallelogram, who can find L? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alberto, help me find L. Awesome. Why? Good. They are supplementary. They equal 180. So I get 45. All right. Who can tell me angle J? 1, 2, 3, 4, 5, 6. Isaac, help me on this one. It's also 45. Why do you know that? Awesome. Opposite angles are congruent. Very good. All right. That seems good enough, right? We don't need to dwell on that. Next problem. It gives us angles. We will find angles in a second, but I actually want to start finding little b. I'm going to find little b first, and that's right here. 4b minus 1, and that's RU. Who thinks they know how they want to start? 1, 2, 3. Think for a second. How do you want to start solving that? How do you find a little b? Megan, help me out. Mm-hmm. Mm-hmm. Awesome. Megan knows in a parallelogram the opposite sides are congruent. So she set 4b minus 1 equal to 23. Add 1 to both sides, divide by 4, and we end up getting 6. Good job. Questions on that one? All right, now let's look at the angles. I want you to be really careful with the angles and think about what are we actually finding. You may be finding the whole big angle, or you may be finding a part of it. So we're going to look at each one individually. The first one says measure of angle RST. RST is right here. That's this angle right here. What are we thinking? Who wants to help? How do I find RST? What are you doing to find that?
I saw the R, the R 30 degrees, and I knew split half, so I doubled that.
Oh, let me pause you. It's not necessarily split in half. This 25 is this angle right here next to it. How does that change your answer, Colin? I think just by 5. They are not an angle bisector. So it is like one side is 30 and then one side is 25. Oh. Oh, you're adding them all up to get 360. Oh, okay. Yeah, we could do that. So Colin's saying he's adding big angle R, S, T, and U to get 360. So how did you like think of that in your head? So what's angle R? What's the sum of those small angles at angle R? 55, good. And so what did you do after that? Not subtract. Divide, maybe? We're doing some crazy stuff. You're right on the right track, but I'm not really following. Who wants to finish that off for me? If we know angle R is 55, how would I find angle S, angle RST? From 180. We can even, you're not wrong, Colin. It's just an easier way to do it. If we just look at the two angles that are supplementary, Michael knows that angle R is 55 and angle R and angle S are supplementary. So we minus from 180 and we get 125. All right, cool. 125. Questions on that one? If you did it like Colin, I probably would have done 55 plus 55 plus 2x equals 360 because we need to divide by 1/2, not minus 1/2. What about the next one? It says UTR. Let's figure out where that is. UTR is right here. It is going to be 25, Maggie. How do you know that? What did you look at to know that it was 25? That angle right there? Ooh, that's perfect, Maggie. Can anyone help Maggie tell her why she knows that that's 25? Jane? Very good. They're opposite. You also can even go all the way back to unit 3 and remember that we've got alternate interior angles. That's what you're looking for. Let's do one more. Let's do TUR. What's TUR? TUR. 125. Why, Allie? Good. Congruent to the opposite one. Okay, I'm a little bummed. We didn't get as far as I wanted to. In my other classes, we did at least one other example. If I have time tonight, I'll do a couple examples and put them on YouTube if you want to watch it, but we're still doing homework. If you want homework on paper, I'm going to pass it out. If you want it online, it's already up. I am going to stop my recording so people on YouTube don't have to watch us clean up.